motion. Take down. In this topic, we'll be discussing about the motion. That is, we will describe what is motion. Then we'll be talking about what is uniform motion. Uniform motion, non-uniform motion, non-uniform motion. Then we will describe speed with the direction. Then we will be discussing about the rate of change of velocity. Rate of change of velocity. Then how to represent graphically the motion. That is graphical representation. Graphical representation of motion. Then we will discuss about the equation of motion. Equation of motion. Okay. By graphical method, method. Then I will be explaining about the circular motion also. So this is the topic 3, and these are the concepts about which we will be discussing under the heading motion in your 9th standard science. Now, let me have the overall mind map of this chapter. State of a body. So we will discuss about the state of the body, whether it is at rest. It's called state of rest, or whether the body is moving, so that is called state of motion, from one point to another point. Under state of motion, when I say motion, we should have a proper definition of motion, is it not? So we have to describe the type of motion. Describing motion. Whether the motion is along straight line, or whether it is uniform or non-uniform. See, when we talk about the state of motion, we should also explain the measuring of motion, how the motion is measured. So this is called measuring of motion. How we measure the motion. And then we will be explaining about the acceleration. This is another important term that you should learn. And when we measure the motion, we take the velocity or speed. Speed with the direction is called velocity. Okay? Now, how to represent this speed with the direction, that is velocity? We can call it average velocity also. So the average velocity, we can put VAV at AV is equal to initial velocity plus final velocity. That is final velocity plus initial velocity divided by 2. This is called average velocity. V is the final velocity, U is the initial velocity. And the acceleration is represented as A. A is equal to the change of velocity, that is in final velocity minus initial velocity divided by T. Then we will be discussing about the under the state of motion, that is graphical method of measuring the motion, that is equation of motion. Equation of motion by graphical method. Then I was discussing about the uniform circular motion, is it not? So, uniform circular motion. This is given by the equation V is equal to 2 pi r divided by T, where r is the radius of circular motion. So this is the overall concept map of motion. Now let us discuss one by one. Let us describe motion, the first aspect. What is rest? A body is said to be at rest when its position does not undergo any change. When the body does not undergo any change with respect to its surrounding, and time, or with time. So when I keep a body like this, it is at the state of rest. But when it moves, there is a movement. It is called motion, is it not? So let me say this is the initial level and this is the final point. So it undergoes a motion. This is the motion. So motion where you can find the change of position, and in the rest there is no change. Now let us define motion. Motion undergoes change in position, is it not? Change in position. For example, you can talk about the sunrise, is it not? When the sun rises in the east, after some time it goes up, is it not? So there is a motion. And also sunset, then different season, change of seasons, is it not? Because of that, why this happens, this change of season? Due to the motion of the earth, is it not? So change of season is due to the motion of the earth around the sun and also about its own axis. Okay. Now we can classify this motion into two. One is controlled motion, another is uncontrolled. For example, when I keep this cell, it goes on. I am not controlling it. So this is uncontrolled motion. So when I control like this, okay, so this is called controlled motion because I am using some external force. Is it not? I can either stop or increase the speed. So this is called controlled motion, and the other one is uncontrolled motion. So controlled motion that takes place at a particular speed. At a particular speed and also at a particular direction. At a particular direction, in a particular direction. For example, generation of electricity. Electricity is generated by rotation of turbine with controlled speed. Okay. with the help of falling water. Then uncontrolled motion. This will be erratic. Is it not? This is erratic and it is zigzag in all directions. Okay, this is called zigzag. Or of high speed. So these are all uncontrolled motions. For example, flooded river. So flooded river. Here controlled motion, the rotation of turbine. Example, rotation of turbine under falling water, is it not? Whereas this is uncontrolled motion, flooded river. Now we can explain about the quantities. The quantities can be classified into two types. One is scalar quantity, another is vector quantity. Scalar quantity, another is vector quantity. Scalar quantity has only magnitude. Vector quantity has both magnitude and direction. So here there is no direction, whereas in this case we have both magnitude and direction in the case of vector. Example, distance is a scalar quantity. Displacement is a vector quantity. Speed is a scalar quantity. Velocity is a vector quantity. In fact, we can define the speed. Speed is equal to distance traveled divided by time. Whereas velocity here is equal to displacement divided by time. When we talk about the distance, we should know the other point, that is origin. Origin is a reference point. Origin is a reference point from where distance is measured. Distance is measured. For example, let me say O is the origin, some reference point, and A is the distance from this origin. Okay, A is the position and A is at 5 km from O, so this is called distance. The distance is given by the SI unit meter. Distance is measured by meter, that is the SI unit. You should know what is the odometer. Odometer is the device in a car. It is a device in a car or any vehicle that shows the distance. That shows the distance traveled by the car. Now let me explain about displacement. Displacement is the shortest distance Displacement is the shortest distance between initial and final position of the object. Right? In fact, distance is a vector quantity. Displacement is a vector quantity. The displacement can be positive or negative, and even it can be zero. For example, let us consider a car is moving from A. It goes here. So this is the initial position and reaches B. From where it goes here, that is C. So what is the initial position of AB displacement? This is the first displacement and this is the next displacement. So AB is the first displacement and that can be represented by AB vector. Do you understand? BC is the second displacement, so that can be represented by BC vector. Now it comes back to original position A. So this is called CA vector. Now what is the net displacement? It becomes zero. Why? Because we are reached to the starting position. Okay? So finally there is no net displacement. So in that case it is zero. Let me consider I am starting from A, go to B. So this is the AB vector. Okay. Now from B I am returning to A. How to represent that? That can be represented as, that is, AB minus vector, minus AB vector, which is nothing but B to A, is it not? So the vector symbol is very, very important. It is represented by an arrow. So this arrow represents the head and tail. So this is the arrow mark and the arrow head, and this is tail. So when I say AB vector, what does it indicate? It starts from A and reached B. When I indicate a B to A, what does it indicate? It starts from B and reaches A. Are you able to follow? So this is AB and this is BA, and this BA can be represented as a negative vector of AB. Are you able to follow? That indicates that direction is opposite, and that is why a vector can be made positive and negative based on the direction. Is it clear? Now I have traveled AB, okay, and then I have returned, that is BA, correct? What is the net displacement? Zero displacement. Do you understand? Because I come back to the original position. Let me say this is a 5 kilometer in towards east, okay, and come back to the original position, that is towards west. It means what? The displacement, the net displacement is zero. So the direction is what? It is indicated like this, but the net displacement is zero, that is null vector. So this is called null vector. Okay, take that. Have you noted down? Now let me explain about the linear motion, then uniform motion, then non-uniform motion. Take that. Linear motion. For example, let me consider this graph. This is x-axis and this is y-axis. Is it not? The x-axis is represented by t, time, in second, and y-axis, here it is s, that is given in meter. Okay. Now if this linear motion is uniform, for every 5 seconds there is displacement, means this will be uniform linear motion. Are you able to follow? Let me consider O and this is A. So OA represents linear, uniform linear motion. Okay. So what do you mean by actually linear motion? Linear motion is always straight line. The motion taking place along straight line. Uniform motion means what? When the body covers equal distance. Okay, equal distance, uniform motion. Take down. What is uniform motion? Covers equal distance. in equal interval of time. Let us consider your car is moving at a 50 km per hour, means you can calculate in next hour it would have traveled in another hour. For example, starting from 0 and it goes in the speed at a speed of 50 km, means in another hour it will reach 50 km, in another hour 100 km, in another hour 150 km. Are you able to understand this? So it means the speed is uniform, is it not? So this is the uniform motion. Got it? Now in the second hour the speed is increased double. Now this is not uniform, is it not? When there is a change in speed, it means it is not uniform. Okay, take down. Non-uniform motion. Non-uniform motion. The object covers unequal distance. In this case, equal distance. Here, unequal distance. Do you understand? In equal interval of time. So this represents the uniform motion. Whereas, let me introduce another graph, and this is non-uniform motion. Why? Because this is t, this is s. Now with the increase of time, it adopts various speed like this. Okay, in short interval it goes like this. Are you able to follow? Here it is uniform, whereas here it is not uniform. Okay. How it can be judged? Because let me consider, see, that is in 1 hour, 2 hour, 3 hour. So here in 1 hour 50 kilometer, in 2 hours 100 kilometers, in 3 hours 150 kilometer. Do you understand this? For example, this is given in second. Let us imagine, usually it is given in second, but we can have it in hour also, or even you can call it 1 second, a few meter like that. So 1 second, 2 second, 3 second. So here say 50 meter, and this is 100 meter, and this is 150 meter. So you take a point, you will get a straight line only in this case. Whereas in this case, for example, in 1 hour you should have traveled like this. In the next, 1 second, in the next 2 seconds there is an increase. Okay, in next 1 hour, see, the value increases like this. Okay, so of course let me say this is 50 meter, and this is 60 meter, and this is 150 meter, like that. Okay, so in 1 hour it is 50, in next 1 hour it is 60, in next 1 hour it is 150, means the speed has increased. Okay, it is not uniform. So when it is a linear like this, uniform linear motion. If it is not uniform, then definitely it won't be linear at all, and not only that, it forms a curve like this. Are you able to follow? So this is called non-uniform motion. Take down. This is uniform motion, and this is non-uniform motion. Okay, draw this diagram. Usually the speed can be measured by meter per second in unit meter per second. So what is the speed, average speed? Let us take average speed is equal to total distance divided by total time. Okay. And usually velocity is represented by v, so v is equal to s divided by t. And we used to call initial velocity u. V, final velocity. And the average velocity is given by initial velocity plus final velocity divided by 2. Usually the unit of velocity is meter per second. And for speed also meter per second, and sometimes it is given in kilometer per hour also. For larger distances it is given in terms of kilometer per hour, but by SI unit it is given by meter per second.